All right. Welcome everybody to the Fall 2023 seminar series. Today's speaker is Amanandir Singh Gill. First of all, this is the GSC team, the group that is kind of hosting the seminar. Roshan and I are co-chairs this semester. Our publicity team consists of Andrew and Avinash. And we have a large support team consisting of Anirban, Swapnil, Mayank, Mohammed, Latif, Falani, Nurian, Suraj, Shavash, and Lewis. And we have our incredible mentor, Dr. Farouk Mistry, who is also helping to host this. If you would like to join the graduate student community, we have regular leadership meetings on Wednesdays at 5:15 over Zoom. If you would like to join that, please either contact either Roshan or I, and we will give you the link to that meeting. If you'd like to also join us, we highly recommend joining the Engage page, which can be joined via this scanning this QR code here. We also have a LinkedIn page and Facebook page. All of that can be gotten from here, or you could also contact us for that. For those of you who either have to duck out early or miss the first bit of seminars, we do record all of them and upload them to YouTube. And you can get to that YouTube page via here or by contacting one of us. For the graduate students at OU, we do have a team room that's available for student use. It has couches, whiteboards, coffee pots, a microwave, just anything if you need a space to get work done or just to relax. Just email us if you would like access to it. And then eventually we'll be putting up a Google form that will have our attendance. Please fill that out so that we have kind of a record of who came and what the general interest in these talks are. And with that, I'm going to go ahead and pass it on to our speaker for today, who is going to discuss ChatGPT and the possible either extinction or rise of an augmented designer. So with that, I will stop sharing and pass it over.
All right, I'll go ahead and share my screen. Can everyone see my screen?
Yep. Oh, you are in presenter mode, though. We can see your notes.
Oh, I don't have notes, but I will fix them. Stop sharing. Let's do this. All right, is this better?
Yes, perfect.
Oh, thank you. All right, good morning, good afternoon, everyone. I'm Amanandir Gill. I'm an assistant professor of mechanical engineering here at Centralia College in Centralia, Washington. The title of my talk for today is Chat Generative Pre-trained Transformer, also known as ChatGPT, Extinction of the Designer or Rise of an Augmented Designer. Just a few pictures on what I do here at Centralia. I run the robotics and automation program. This ties in pretty well with what I've done for my research in the past, which is look at engineering systems. These industrial systems are, kind of what we model with our function models, and it's kind of nice and that I get to, work on these more hands-on and spend time building circuits and programming robots and looking at industries that make food, make chips, make airplanes, and take my students on plant tours. So that's my teaching job here at Centralia. This is a research project that I picked up sort of at the end of last year when ChatGPT came out. It became the news everywhere, and I was really interested in seeing how it's going to impact design ideation. And that was my initial exploration. So Back in winter, I did a presentation into my initial investigation and what I found, which also then became an ASME IDTC paper, which I was able to present this year at the Boston IDTC. And since then, we have added a little bit of more work to that past research. I was able to get access to four-year undergraduate mechanical engineering students at the University of Washington at their Tacoma campus, and we were able to do a user study with them, which I will also explain in this talk. So for some of you who have listened to this talk before, I will go over some of the stuff that we've already talked about, but it's important to the conversation, so I'll go over it one more time. All right, let's start with the background. What are function models? So in the engineering systems design, in the systematic design process, which is pioneered by Paul and Weitz in their seminal text constructions layer, initially, when you start designing a system, the first step is task clarification, followed by functional requirements. And then once you have the functional requirements down, you can understand how you can how all of those requirements are going to interact with each other as subsystems so that you can accomplish the overall function of the system that you're trying to design. So it's an iterative process, and function models are one of the first outcomes of this process once the specification has been understood. And as you can see, a model, an example of a function model has been put up there on the slides. Typically, these function models are verb-noun pairs. So you import. So, for example, import is a verb and electrical energy is a noun. So these verb-noun pairs basically identify what the subsystems are going to do and how those subsystems interact with each other and the environment. So the functions are typically written in boxes, and then the flows are drawn as arrows, and they're labeled with what those flows are carrying. They typically carry energy, material, or signal that can be mounted on the material or mounted on the energy, right? So it's essentially a graph, and once you have your functions modeled as a graph, there's a lot of mathematical reasoning that can be done on it. So that's my starting point. My previous research has focused on function models. So I want to understand how ChatGPT would do some of the stuff. So as an example, a function model can be used both to reverse engineer a product and also to ideate for a new product. So here we've basically taken apart a simple household product, which in this case is a hairdryer, and we've mapped each of the physical element or a physical subsystem in that product to a function that it accomplishes. So as you can see, most of these elements will correspond to a functional requirement that needs to be functioned in order for this hairdryer to accomplish its overall function, which is how it can import air and then export hot air using electricity. That's the overall function it's accomplishing, right? Typically, function models are solution neutral, especially if you're trying to do ideation using function models. When you're making function models, you don't want to think about necessarily a product as you're designing. You want to think about what functions you want to accomplish and how those functions might interact with each other. Form is not, or solution is not a concern at this point. All right. So now that we understand something about the design process, something about function models, what were my research questions? So my research questions were, the first one was a functional basis. So I'll reiterate a little bit. Functional basis is basically a vocabulary that consists of verbs and nouns. I may have missed this. No, yeah, correct. Functional basis is basically a vocabulary that consists of various verbs and nouns. They were formalized back in the 1990s through an NSF study, Stone et al. Oh, I heard an echo. So my first question essentially was, since this ChatGPT is a large language model, can it do basic language queries, such as can it distinguish between verbs and nouns? Now that it can distinguish between verbs and nouns, can combine those verbs and nouns, which basically forms a function. It's a verb-noun pair. My second question was, can ChatGPT generate function models? The answer to the first research question might be quite obvious, since it's a language model. It has capabilities to process language. The second one was not so obvious, and I was trying to see if I can create function models, kind of like the ones that I just showed you in the previous slide. Can I create those using a language model? And the second one was, if I wanted to create a function model in more detail, can more granularity be added to the function model that's given to you by ChatGPT in the first go? And then the next question was, can ChatGPT generate working principles? And the idea behind this is, can I ask the language model about each function, and can it tell me how that function could be accomplished, right? So my first question was, can working principles be generated for each subfunction within the function model? My second question to it was, can working structures be generated from the function model? So can it combine a bunch of working principles and tell me, hey, this is how you can combine working principles to have a working structure that will accomplish the function? And then now that I have these different working structures, can it basically look at two different working structures and tell me if there's any similarity between them, right? Did it basically give me the same working principles but with different names, or does it not know if they're different, right? So language is one thing, but using language to describe physical reality and draw meaning out of that is another thing. And that's what I was trying to understand with this question. So the last question, which is the new addition to this research, ever since I've presented this to this group in the past, and then also at Boston, is the fourth research question. Is there a difference in the solutions generated when designers use ChatGPT as an ideation aid? I've worked with function models for my entire graduate student career, and I wanted to see if I gave someone a little bit of instructions on, hey, this is the design process, this is how function models, working principles, working structures, physical products, this is how it works. And by the way, here's ChatGPT. Can they actually use it to their advantage, right? So that was my fourth question. So within that, the way that I asked, or that I investigated that question was, I asked whether is there a difference in the novelty of the solutions when people use ChatGPT versus Google to look things up? Is there a difference in the variety of the solutions they generate when they use ChatGPT versus when they use Google? And then the last one, is there a difference in quality when the same thing happens? So that's something I wanted to investigate, and that's the user study that I will describe today. Large language model-based AI tool, ChatGPT. Well, as soon as ChatGPT came out, there was this entire chatter about this is the greatest thing ever since sliced bread, to this is the end of the world, right? And everything in between, right? People who work white collar jobs thought this is the end of white collar jobs. People who are students thought this is the end of education, because now ChatGPT will tell you everything. What's the need to learn anything at school? And so the responses that came out of this were interesting. So is your information or business safe, right? Are public school districts concerned about AI and ChatGPT and cheating? We had a big conversation here at our school, especially with the liberal arts faculty. And then there were schools that were saying that ChatGPT is amazing, we still won't allow it. And then some colleges were saying that they probably need to adapt to this new reality. And that was the response in education. In other fields, they were trying to see how they were transforming essentially law. Law is a lot of text, And there are companies that have since come out and they do a lot of automation in local, the law stuff, right? And then Bill Gates came out and said ChatGPT is every bit as important as the PC, and the internet, right? And then students cheating. So there was a frenzy of the responses to this tool, which is a free app on the web. And so that's where my curiosity came from. Why do I even want to investigate this? So a little bit of some of the past stuff I've done. And in the past, in order for a computer to generate function models, which was mostly what I did for my dissertation at Florida Tech, was I basically went in and I had to say, well, these are the logical rules that a function model needs to operate under. And well, once I have created a function model using those logical rules, which have to be consistent with topology, they have to be consistent with physics. And then once I create one function model, can I keep on evolving that function model, right? To get better results, to get more detailed answers, to get more relevant answers, and then to also decide what is a good stopping point for them. And so what I used in my dissertation was something called genetic algorithms. And in order to accomplish that, I first had to define, things in genetic algorithms terms, a chromosome, which consists of the vocabulary and the topology of the function model. And then I had to basically develop the algorithm on how these chromosomes are going to be manipulated. And they were basically doing, they were generating offsprings in each generation. Those fittest offsprings were being selected, and then they were propagating until a good stopping point was reached. So there was a lot of logic and physics and algorithms that were going into generating function models. And now that the large language model has come around, I wanted to see how that would, sort of change things. So as I mentioned before, um, you know, um, with my dissertation, I came up with about 72 rules, and we identified these essential functions, and we put count rules on them, topology rules on them, type rules on them to make sure they're logically and physics-wise consistent. And could they go from a random function model to actually something that's useful, and then see how much variety there is in the function models that are being created. And then, like I said, just using it on a VBA based app on your PC was not the most computationally effective either. But with ChatGPT, even though you're accessing it on your PC, you're using the computing power that OpenAI is providing to you. You're using the algorithm that not you're writing, but OpenAI is writing the algorithm for you. So it was extremely important. It became very important for me to investigate this. And this is kind of the interface that I was using. If you've used ChatGPT, it's a chatbot. It's as easy as it gets as far as interfaces go. But the interface I was using at the time was obviously had a bunch of buttons. You had to, write out for user studies, small script for people to understand what each button does. You have to program each button's functionality, and then even when the results come out there, you kind of have to decode them to make a function model out of them. It's a bunch of ones and zeros, and then you have to kind of write them down, map them out manually, and make a function model. So there was a lot of human effort and computational effort that was going into creating function models. So that's why I decided to go to ChatGPT and see if they were doing things differently. So to answer some of the research questions, I went into what's called the Playground for ChatGPT. This is not the standard chatbot. This is a paid version, but they also give you a certain amount of computation for free, and that's what I used. I ran out of my free computation time and the amount that's allotted to you after this, but I do intend to go back and get a paid version for this. This is so interesting. But the difference here is it lets you change some of the parameters, right? So it'll let you choose which large language model you want to use, which in my case was Text DaVinci. That is OpenAI's most advanced language model, so I chose to go with that. Length of the response, how much response do you need? The longer the response you ask of it, the more computational power it'll take from you. And then you also get to sort of play with two different knobs, one of them being temperature, the other one being top P. So temperature goes from 0 to 2 essentially, and it basically controls the randomness. How random is the output going to be? 0 means least randomness. So I was not looking for random answers. I was not looking for absurd answers. I wanted something that was going to be relevant to me, at least for this part of the study. And then top P basically controls how diverse the output is going to be. So I put it to 1, which means there was a medium amount of diversity in the outputs, right? So as you can see, that's the screenshots of the playground. ChatGPT Playground. So the first one research question was, can you spot the difference between verbs and nouns? And I asked, initially, can you classify these words into verbs and nouns? And the ChatGPT answer is highlighted in green. And it says, these are the verbs, these are the nouns, pretty simple. So then I gave it a bigger data set, something that's more relevant to the functional basis, and it passed that test with flying colors as expected. The next question was, can ChatGPT create verb-noun combinations? So if you look at the top left, I gave it, I said, hey, these are a bunch of verbs, these are a bunch of nouns. Can you combine all of them just to see also how it works? Whether it's going to do just one combination or really it understands all combinations, as in every single option. And so if you see the answer given in green, and if you see the scroll bar, it does not go all the way down. It would have been multiple screenshots before it had gotten all the way down, but it combined all the verbs, all the nouns, every last one of them. So it understands instructions. It follows through with them pretty decently. So now the next question is, can it generate function models, right? All the stuff that I had to do prior to generate function models, all the genetic algorithms, and that's not the only one way. Other researchers have used neural networks and such to generate function models before. Computationally, function models have, as far as I would say, there has been limited success in generating them computationally before. So my question to it was, design a function model for a product that will import electricity and air and create hot air on the outside. So I'm telling it very clearly what my overall function is. And it's basically said, hey, these are the inputs, these are the processes, these are the outputs, which is spot on. So it discerned that the air and the electricity are going to be my inputs. It discerned that the processes I will need is I will have to convert electricity into thermal energy. I will have some way to compress the air to cause that motion of the air. And then I will have to mix the air and thermal energy. So that was intriguing. It hit the nail on the head, and the outputs are correct. So hot air is what I need on the output side. But that still doesn't, like, in your head, look like a function model. You still have to see how these different processes interact with each other. So I changed the input prompt and I said, design a function block diagram representing a product that will import electricity and air and will create an outflow of hot air, right? So if you notice, I've gone from function model to a function block diagram, which is I'm looking for something that's drawn out, right? So diagram is the keyword here. And then the rest of the stuff is, even though reworded, but it's kind of the same. So the first answer it gave me was the first text highlighted in green that says, import electricity, import air, combine electricity and air, heat air, outflow of hot air. So that's okay, that's correct. And then I asked it again to add some granularity to the function model it gave me in the first go. I said, how to import electricity? And it told me electricity source, power conditioner, transformer, power distributor, added electricity meter in there, and then said import electricity. So basically, it has given you most of the functional circuits that go into your wall plug-in adapter, right? And then I said, well, how to import air? And it says you will intake the air, you will filter the air, and you will have a fan, and then import air. So notice here, I said in the beginning that the function models, especially if you're using them to ideate, have to be solution neutral, and you're only thinking about the functions, you're not thinking about the form at this point. But it's ChatGPT. It's hard to convey that to ChatGPT. But so far, it was doing good until it said electricity meter and then fan. And then my next question was how to combine electricity and air. Again, it tells me what to do, but if you notice, it's starting to give me some of those working principles. Essentially, it's saying, hey, you can use a heating element. And then similarly, how do I heat up the air? Says combine electricity and air, which is it's kind of hard to combine electricity and air unless you're creating an arc of some kind. And says heat exchanger, heat air. And it's like, okay, I see heat exchanger, that's understandable. And then says create an outflow of hot air. That's what I asked it, and it said heat air outflow valve, outflow hot air. So it meant to add granularity. I apologize. It goes from just giving me the functions to actually giving me the solution. So I was like, okay, that's great. Let's see if it can actually find solutions for this. So I asked it how to convert electricity to heat energy, and then it gave me a bunch of answers. I could use a heating element. I could use it says commercially available. I could use resistance heating. Great. I could use an electric arc furnace, even though that'll be hard to carry around in a hairdryer. Induction heating elements, and then some dielectric heating elements. Pretty spot on. And then I was trying to see if it could find a product that would combine all of these working principles and say, hey, this is ready to go product that you can use, right? So I said, what are the products that are close to this design? And it said electric heaters, air heaters, and space heaters, right? So notice that even though in my head the solution was, oh, hair dryer, because that's kind of how I trained in my undergrad. Hair dryer was the go-to example. Hair dryer is not here. I was like, oh, interesting. So the next thing, and these are stock images from Amazon, so none of that looks like a hair dryer, but it is the same function. Like I said, functions at that stage are supposed to be solution neutral. So then I said, okay, let's see if let's see if it understands how products are similar or dissimilar, which was my third question to it. So I asked ChatGPT the question, is a hairdryer close to this product family? And it said yes. Now, how the models work in the background is fuzzy to me, but the answer is spot on. And then the next thing I ask it is a heat gun close to this family? And said, yes, a heat gun is close to this family, which is also the correct answer. And this was very similar to a paper that we had presented at the IDTC in 2019. We had a bunch of products that we showed to third year engineering students. And we basically we said, hey, here is product that you are supposed to design. And if you were to take design inspiration from that product, could you tell which of these other products that you will take design inspiration? Are they structurally similar, or are they functionally similar, or somewhere in between? And on the x-axis, we are looking for functional similarity, goes from a scale of 0. There's a 0.5 for that glue gun, and then a 1. And then on the structurally similar y-axis, we are looking at structural similarity. So blender, not at all similar to a hairdryer, but hand drill, sure, it is very structurally similar. And then glue gun is somewhere in between, right? And the responses we got, and there was a whole host of such questions. I've just taken one that seems to be relevant to the problem I was working on. 27 respondents said that the space heater is similar to the hairdryer. 30 respondents said a heat gun is similar to a hairdryer. 18 said the glue gun is functionally similar. 1 said the blender is functionally similar. And then 5 people said the hand drill is functionally similar. So you can see, most of the people went with heat gun and space heater, and that's kind of, what ChatGPT is giving out. It's not saying 5 mechanical engineering juniors said hand drill is functionally similar to a hairdryer. Somewhat, yeah. I mean, electricity component, the motor, that's sure. Blender, sure. There's some functional similarity there. I can totally see it, but ChatGPT was pretty spot on. So now that was most of the stuff I did as an individual with some experience in engineering systems design. So I wanted to take this question out to again mechanical engineering seniors at a four-year institution, and I wanted to see how they would use ChatGPT and what kind of solutions they would generate. So I came up with a user study, and the idea behind conducting this user study was we would go to a four-year school and we will split the students into 2 groups. One group would be called the ChatGPT group, and they were given access to ChatGPT to answer the questions on the quiz or on the user study. And then the other group was called the Google group, and they were encouraged to use Google as much as they want to answer the stuff that was on the user study. And then this was in a lab setting. It was a structures lab. So the students were doing the lab class in which I went to do the study. And that was going to be the lab assignment for the day, just to do the study. The students were encouraged as a result to not look over into their neighbors' results or screens, since it was a classroom setting. They were sitting in close proximity to each other. Everybody had a computer in front of them. So for the study, I printed out the study tool as a study packet and handed it out to the students. I gave them writing instruments. Students using ChatGPT, they were encouraged to use their laptop or tablet, but nevertheless, they were given out a study packet too if they wanted to use ChatGPT prompts to answer the questions. And then for students who simply were using the Google search engine, but also encouraged to use a laptop or tablet to use Google. But again, they're encouraged to write stuff down on the study tool. So for the ChatGPT group, it was essential to use ChatGPT. They did not have the option to not use ChatGPT. For the Google group, it was highly encouraged that they use Google to answer those questions, because if not, they would be completely lost. ChatGPT is a chatbot, so the way you interact with it is kind of structured a little bit more than sort of how it is structured with Google. So there was that. And then after completing all problems, students had to take a survey. So in order to do training for the students, I basically did 5 training videos. I was traveling up from Centralia to Tacoma, and in my travel time, SJ, my collaborator at University of Washington Tacoma, started the study. They were watching the videos as I walked into the room where the study was taking place. All the videos were uploaded to my YouTube channel, played on the just the screens in the lab setting. Here's a link for them, and here's a screenshot of all the videos that were up there. And then since they were public, within the study, if the students wanted to go back, take a look at some of the videos to clarify some of the concepts, they could have done that. I must tell you that some of the slides I used in the training videos are essentially some of the initial slides that I've shown you and talked to you about. So here's the study tool. Basically, and we gave them plenty of space after each sort of problem statement, and then each sub problem statement. So the study tool came out to be like a 14-pager packet that we handed out to the students, right? So ask them your name, your group, and then we asked them to solve 3 different design problems. The first design problem was design a system that will use electrical energy to generate an outflow of air. Pretty standard, easy problem. everybody at some point has seen a heat gun or a hairdryer walking in the mall, at their home, things of that nature. The second problem statement was, can you design a handheld system that will use electrical energy to cut through a sheet of plywood, right? So could be, a jigsaw, or, any kind of handheld saws that you would find in a makerspace, or if you've worked with your hands, or in your family's garage, or if you visited Home Depot or Lowe's, you would probably see something that will cut through a sheet of plywood, right? And then the last problem statement was a little bit more difficult, where they were asked to design a system that will use electrical energy to produce potato salad from raw potatoes, right? So I took one of the pictures I showed you initially. I took my students out to Reasor's Fine Foods, and they make they're the biggest manufacturers in this area of potato salad and chicken salad. So I was thinking, the idea was to go from a very easy problem to a very difficult big problem, and see how students use ChatGPT or Google, and how they do on all these three problems. And then within each problem, for each problem statement, we had 4 questions that the students had to answer. The first one was, create as many unique function models as possible in the space below. Within each function model, try to add as many functions as possible. The second question was, for each function created within the function model, list all possible working principles to achieve that function. The third one was, identify all possible combinations of the working principles that will allow you to achieve the overall function defined in problem statement, the previous problem statement, essentially. Identify and write names for all possible commercially available products that can achieve the overall function defined in the previous problem statement. So problem statement number 3. So we got the responses back. And then me and my collaborator, Dr. S.J. Lee at the University of Washington, we sat down and we wanted to grade the solutions that we got. So we came up with this grading rubric. We were looking at novelty, we were looking at variety, and we were looking at quality. So for novelty, it was a 5-point Likert scale, going from not at all novel to very novel. The way we defined not at all novel was, this is an expected solution. And then as an example, for the first question, think of a heat gun, think of a hairdryer. If you have components, or if you have ideas that resemble that product, you get a 1, right? That's not a very novel solution. It was kind of very expected. And then, you go up to, let's say, number 4, where let's say you want to, heat up the air using laser, right? Because typically you would not use laser as to heat air. Sometimes you can use it in, say, laser metal sintering, so it's still usable, but it's somewhat novel, right? And then extremely novel is, let's say you have a small mini plasma generator that you're using at a heat source, kind of novel physics, novel mechanisms involved. So that's the way that we decided the grading rubric for novelty should be. And basically these novelty metrics are evaluating the questions 2 and question 3. So with variety, we wanted to look at the number of ideas they generate, number of physical principles they create, the working principles, and the embodiment design, and any details, any sketches, any links, anything else they wanted to put in there. And this was a weighted sum, so we gave a weight of 5 to the number of ideas, and I'll talk about that why we picked 5 in a second. And then 10 for physical principles, 6 for the working principles, and then 3 for the embodiment and details. We were not expecting them to put anything, but just on the off chance somebody wanted to put details in, they get a point of 1, right? And the last thing, we want to measure the responses was on quality, and within quality, we're measuring three things. We're measuring efficiency, we're measuring feasibility, and we're measuring completeness, right? So how complete was your solution? If not all complete, which means there are some very essential subsystems that you need to accomplish this task at a very, very basic level, but you miss that mark, you get a 0.1. And then if it's very complete, so you have all the systems, subsystems that you need to accomplish the function and lots of detail, then you get a 0.5. Feasibility and efficiency kind of go hand in hand. If your solutions are, let's say not very novel, pretty commonplace, they're pretty efficient as it gets, and they're also very feasible since they're so, commonly found. We had to customize this rubric in the novelty aspect for each of the three problems. So within novelty, we were looking at these 5 functions that must be accomplished so that you can solve that problem statement. For example, for a hairdryer, you should be able to handle electrical energy, have some control signal, convert electrical to thermal, electrical to mechanical, handle the air, right? Similarly, for the second problem statement, I was using a handheld tool to cut through plywood, right? You have to have some kind of rotational or translational energy. You need to have some kind of way to handle, say, plywood. And then you have to have some kind of way to handle electrical energy. And similarly for the last one, you need to handle potatoes differently, ingredients differently. That's at least what I saw how Reesers had their plant set up. They had to handle electrical energy, handle the control signals, and then also move things around, so electrical to mechanical energy, right? And so we created rubrics like this for both of us and for all 3 of the problems. And it's just a screenshot of those grading rubrics. Here's a quick summary of the results that we got. Quantitative results are great since we're trying to do some measurement, but there were also some qualitative observations that were made by looking at the solutions. So the results were not very unexpected, but they were definitely interesting. So if you look at this table up here, so we separated out the Google group and the ChatGPT group. So in the novelty side of things, ChatGPT folks consistently score higher in each one of the problem statements. So 1, 2, 3, they score higher in all 3. But the trends are similar. So if you look, the novelty scores are higher in the first problem statement, which is one of the easier problem statements, and it dips for both the groups as you go down. So as the problem gets harder, the novelty scores go down for both those groups. Something similar happened with the variety scores. So for each of these 3 problem statements, the variety scores consistently go down as the problems get difficult. However, the ChatGPT groups were able to get a higher score on variety compared to the Google group. Quality is an interesting one. So in quality, the Google group and the ChatGPT group, the trends are still similar. As the problem gets more difficult, the quality drops consistently. But if you look at the scores, in the first one, the Google group and the ChatGPT group are not that different. They're almost the same as far as the quality goes. In the second one, there is some difference where ChatGPT group folks do score higher in quality. But in the third problem statement, funnily enough, the Google group scored higher in quality for the third problem, right? So, and I will delve a little bit deeper into these in just a second. So some of the observations, some of the more qualitative observations were that the ChatGPT group scored higher in every single metric, with the exception of the quality for the third problem statement. And the answers provided by the Google group resembled in similarity with the training provided. So they were using a lot of the terms from the functional basis, a lot of the terms that I had put up in my training, right? So that was quite interesting. But the ChatGPT's group's responses were, I was hoping for more, using that as sort of an ideation tool and go from there. But most of them just simply use what ChatGPT was generating for them. And it seemed like the Google group folks were more discerning, where they were looking at, okay, does that make sense in real time? But some of the responses that I saw come in from ChatGPT group, sometimes it seemed like they had just copied pasted whatever ChatGPT threw out at them without really giving it a thought if the responses were relevant. It also seemed as though the students in the Google group, they were putting more effort in finding relevant information. And like I said, some of the ChatGPT folks, they used the tailor-made answers without questioning them, which is not entirely unexpected, right? So it was clear that, when there was no existing solution, so for the third problem, ChatGPT folks did way better than the Google folks, because if you go to Google and you're looking for a machine that'll do this, Google can show you a bunch of different things, show you a blender, show you a knife, show you potatoes, show you how to mix ingredients, but it's not going to show you a system. And that's in the variety the ChatGPT folks were able to leverage the language model's ability to sort of give them some hints on how they would accomplish or how they would go about designing this whole system that takes potatoes and makes a potato salad out of them. A little bit more on the results. I've put up the score for the Google group and the ChatGPT group, a quick summary of all the things that I had calculated. I do have my friend SJ's calculations too, and I'm still working on doing an iterative reliability analysis. But for the first question, for the first problem statement, we compared what we scored both the Google and the ChatGPT group, and it was marvelous how similar both of our gradings were. So I'm sure when I do the iterative reliability analysis, I'm going to find something similar. But for representation purposes, I've only put up my scores, what I've graded the solutions up here. And you can see some of the trends in this slide. As I said, when we compare just the novelty, again, the blue team is the Google team, and the red team is the ChatGPT team. The color coding here, but I should have done that on the graphs here too. So as you can see, consistently on the novelty for all three problems, ChatGPT folks do score higher than the Google folks, but as you can see, that difference kind of is really, really high on the first one, and then kind of drops for the second and the third. Similarly, if you look at variety, ChatGPT folks do score consistently higher than the Google group. And then there are, for number three, as I was saying, there's really no ready-made solution for this whole big system that'll basically take potatoes and give you potato salad on the other side. So Google didn't have much to say about it, but ChatGPT did, and that is reflected in the variety. Quality, completeness, efficiency, and feasibility. ChatGPT folks and Google folks were not too far apart. Actually, for the third problem, the Google folks outdid the ChatGPT folks. So that was very interesting. And here's, this is still, as I do more study with this, more research questions keep popping into my head. And, the next two big questions that, I have in my head as far as seeing how ChatGPT could be used as an ideation tool in engineering systems design. I have two big questions. One is, how putting in different prompts changes the output that you get from ChatGPT. So if you're putting in the different prompts for the same problems, is there a difference in the novelty, variety, and the quality of the solutions? And then also, if you keep giving the same prompt again and again and again, time after time, is the novelty, variety, and the quality still consistent? Because the prompt is consistent, but it's just that you're giving that prompt again and again. Or does the quality significantly go up, significantly go down, so that we know if we're ideating well? Don't really pick up on any ideas ChatGPT gives you until you ask it 5 times, right? Something of that nature. So that'd be a good protocol to have if this tool is to stick around in our practice. And the second is, since I did this user study with a junior mechanical engineering students, and so I would like to see how expert designers can benefit from ChatGPT. We've spent lots of time and effort and years into understanding ideation, understanding engineering systems design, understanding function models, so on and so forth. So how, if a good amount of expert designers got together and used this tool, how would the outcome be different, right? Does the novelty, variety, quality go significantly up, or does it significantly go down? Is it any different than when designers team up versus designer teaming up with AI? So that's something I would definitely like to explore. In the acknowledgements, I really, really want to thank my friend and collaborator, Dr. S.J. Lee from the University of Washington, Tacoma, for facilitating this user study, and their entire department for getting the IRB through and letting me through at their institution to conduct the study. That's it. Thank you. If you have any questions, I'm here to answer them. If you would like to connect with me on LinkedIn, here's the QR code and you can scan it. And if you want, I can stop sharing my screen. Great.
All right. Do we have any questions from the audience?
Sorry, I have a question, but it's really related to the research. I want to know, have you ever had any idea about how can ChatGPT help students and teachers in studying and learning to improve their learning styles or learning objectives?
That would be interesting. Some of the students in my robotic microcontrollers class last spring, they were not the most proficient with writing sketches on the Arduino, and they were using ChatGPT to come up with sketches. It was interesting because they got pretty decent answers, but the limitations were when they had a new sensor that they had just bought, maybe its documentation was still not yet up there, and that was sometimes an issue. But like we're trying to use that as a tutor, but I just started my first week of classes. We'll see how we navigate it, but I'll keep you posted.
Thanks.
All right. Any further questions?
Yeah, I have one.
You can go for it.
Yeah. Hello, Dr. Gill, and thank you so much for the presentation. I was wondering, now we have two versions of ChatGPT. One is 3.5, and another one is 4. So I was wondering, did you do any research with ChatGPT 4 and found out, is there any difference between both of them? Because many people say that ChatGPT 4 is really good compared to ChatGPT 3.5. So yeah, what's your take on that?
I'm not. I think that would be interesting to see, although my guess is the difference is going to be minuscule, if that, because their large language model is still, they're still using text Da Vinci. Maybe they've made some changes. Maybe now it connects to the internet in real time. I have not really looked into that, but my guess is the changes are going to be minor. It's still a large
Mm-hmm.
language model, still kind of works the same way. So.
Oh, okay. Yeah. Thank you.
Any other comments, questions? I think what would be neat is if people could tell Amaninder what they could use, what you could use in your research based on what he has said, and what perhaps he may be able to use from your research. That would be very helpful, because it's not just a one-way street, it's a two-way street in terms of how we are setting this up. So he's come along and he's framed the problem from a design perspective, and it's beautifully done. And he's gone through systematically in a way of answering questions. Now, all of you, in terms of doing fundamental research, have research questions. Could you use ChatGPT the way he's set up to frame your problem better? That's the question I'm asking you. So then you get value out of what he has said. Otherwise, it goes through one ear, comes out of the other. So Rachel, what about you?
Well, I've already used it a little bit for just writing really basic functions, just to speed up the process a little bit. That's most of what I've been using it for, actually. Although I haven't recently, because it feels like it's gotten worse at that over time. I don't know if that's just my own personal experience, but I've always double checked that the functions did what it said they did. But it feels like I have to go in and fix things more often these days. So I stopped using it recently because it was getting to be too much of a hassle.
Interesting.
Yeah, I do kind of have a philosophical question, but I don't know if that'll derail the current conversation.
Go for it.
So you were kind of mentioning that some students would just kind of probably copy paste answers directly from ChatGPT into the thing. One thing I've been worried about, I've been talking to other like grad students or professors or things who work with undergrads, and they've been dealing with this problem of grad students just directly copy pasting ChatGPT into like solution guides. And I'm wondering, there's something I worry about, which is like, to develop a skill, you kind of have to practice it and get better at it. For some skills, like for instance, writing, either scientific or creative, you really need to kind of practice it and do those kinds of things. But if we have ChatGPT to just instantly give you like a good like written work, is this a problem in the first place? Do we need to hone these skills anymore?
So that's a conversation we had with the English department. They run the writing center here, and those are the the more creative in an artsy way people. And what they did was, as soon as ChatGPT came out, they said, "Why don't you use it? Use it." And they said, "Well, you can write in Shakespearean voice, you can write in Poe's voice or whatever." And they kept asking students to just do this activity in class again and again and again. And they asked, if you had, generated something in Edgar Allan Poe's voice, and then the other person had done something else, you exchange it. And after a while, it kind of dawned on them that it's a little clunky. There's something that's just not natural about how sentences are being created. And then they started trying to ask it just to write stuff up about things, and they were like, what I gathered from the discussion was that the students who are involved in our student magazine and the literary club, things of that nature, they were like, yeah, after a while something's off. But where they found some value in it was, let's say most of the students, at our campus are transfer students. They're going to transfer to four-year school, which means writing statements of purpose, which is an arduous task. And so to find, good starting points, sometimes you have that writer's block. And it seemed like with ChatGPT, they were able to sort of get past that writer's block, get some prompts, and get that creative process going. That's and that's kind of my stand too. Like, if you're stuck with writing an Arduino sketch, for example, in one of my classes, go ahead and get something from ChatGPT, right? But I will, if it's a small class, like about 8 students, so if they tell me yes, I use ChatGPT for it, then they have to write an explanation of what each line of the code is doing. But that's, again, added labor, questions about assessment. And I think that's conversations that each institution needs to have at its own level and pretty urgently.
Mm-hmm. Thank you.
Anybody else? Arshit, you had some comments.
Yeah. So I'll do it two ways. So first I'll tell what did I actually derive from your presentation and ChatGPT. So I've been using ChatGPT for two purposes. One is to ask it for some computational research methodologies and characteristics of involving CPSs that I've been working on. So that's been good. But the other part that I ask it, that what are some latest research papers that I can access to read about the evolving CPSs. So it does provide me with those citations, but when I enter those in Google, I actually reach to an error page. So I'm not able to access. Yeah, it mixes the authors and the titles of the paper, and I never reach to the paper.
Yeah.
So regarding that, I'm facing a lot of problem. And the other part, that how can I add to the thing that you were saying. So
Sure.
at the end, you finished up saying that how can we actually combine the designer and the AI together. So that's what actually an evolving CPSS talks about. It talks about using our own cognitive space as a designer into the solutions that ChatGPT actually provides. So what you are also doing basically is using the solution given by ChatGPT related to function model, but using your own cognitive space as well to understand that it is actually correct or not. So that's where an evolving CPSS can actually take place. Also, I recently saw that when there was a lot of traffic on the website of the ChatGPT, there was a prompt message on the website that we are currently working on scaling our system. So this indicates to another important characteristic of such systems, that is scalability. So they actually scale their network according to what the traffic is and save their computation resources. So that's my comment on everything.
Yep. Even when I was using the Playground, if you ask it to generate the biggest response it can, which is 4,000 characteristics, I believe, the free computation power it gives you initially before you pay for that stuff, it eats that up. So if you say I want 4,000 word answer, and sometimes it'll say too much traffic, and then if you bring it down to, let's say, 500, it'll do it right there, right then. So
Yeah.
yeah, it's definitely, scaling is definitely an issue.
What happens if you ask ChatGPT to compare the Google answers and the ChatGPT answers, give it the categories that you looked at?
That would be interesting to see how that happens. For that, I will have to digitize the Google answers, because most of the students in the Google group, they kind of wrote down their answers on a piece of paper. But most of the ChatGPT folks decided they wanted to, copy and paste whatever ChatGPT was giving at them. But that would be definitely an interesting study now that we have a good data set.
Anything else? Camilo, anybody? Well, Rachel, I think we should wrap it up.
All right. Well, thank you guys for coming to today's seminar. This was really interesting. Again, if you had to duck out for a minute or you came in late, we are recording this and we'll upload it to the YouTube page whenever we're done. If you have any further questions or comments, feel free to email Dr. Gill. And I think you also put up your LinkedIn.
Yes.
So yeah, I think that about does it. Thank you guys for coming.
So I'll
Thank you very
stop
much.
recording
Thank
and
you.
we can continue.
Bye.